I will be talking about deploying and configuring Zabbix 5.4 in a multi-tenant environment, and how I think Zabbix is finally ready for like a real multi-tenant use case. And we'll talk about multiple features regarding that. About myself, my name is Artūrs Lontons, once again, technical support engineer, consultant, and trainer at Zabbix. And let me share my screen. There we go. You should be able to see it. So let us begin. So we're going to start with a couple of simple things. We're going to start about why and how, from the monitoring standpoint, Zabbix supports these multi-tenant environments, and what are the requirements for such environments. Of course, one of the key requirements, since we have multiple customers, we need to have a granular role or permission schema, right? We need to be able to define different roles for different customers and things like that, and limit what they can access. Of course, since we are supporting multiple customers with our Zabbix instance, either a single instance or multiple instances, all of them will need to have the ability to process large amounts of data. Have multiple customers from which we're gathering data. Different customers can have different requirements for update intervals and things like that. So we need to make sure that our instance performs well and can handle large amounts of history, data, many events, and so on. We need to have redundancy, definitely. If we're doing internal monitoring for our own company or for our small home office or something like that, of course, if the server goes down or the database goes down, it's maybe not as big of a deal as if we are providing a service, and this is how we earn our pay. This is how we earn our living. So clients, of course, won't be happy if something isn't available, and we may lose a customer. So redundancy is quite important. Same as scalability. If we cannot provide scalability to our customers, say right now we're monitoring 1,000 devices, in the future we'll be monitoring 10,000 devices. If we tell our customer that, hey, we won't be able to do it, the customer is simply going to leave for another solution, most likely. So we need to have our environment, our infrastructure defined in a scalable manner. And of course, different customers can have different monitoring approaches. Some may be fine with utilizing agents. Others maybe want to have SNMP checks. For customer number 3, maybe he has a very custom set of applications that we're monitoring via scripts, and so on. So let's just quickly go through the benefits of these monitoring approaches, just so we're aware what we're working with here. So we can have agents monitored in passive mode, meaning they can be polled, and active modes, meaning they can send traps. This is quite vital, actually. Once again, similar to how Igor's presented a real-life use case, I've also encountered use cases where different customers have different networking environments. Sometimes they're not fine with polling, with someone connecting to their device, their network device, for example, or their server, and they wish to have only agents running in active mode. And this is perfectly fine. We support it. Also, different customers will have different platforms. Agents also support that. They support execution of external third-party scripts, either via user parameters or custom item keys, for example, system.run. We can also read log files, event logs on Windows, and essentially deploy agent on any sort of OS. So this is great. This already adds us a lot of flexibility. Of course, agent won't be an option always. So we have many other methods, SNMP, HTTP checks, IPMI, which is quite rare, but it's still there, SSH, can do basic checks like port checks and pings, can monitor databases, Java applications, execute external scripts by the server, proxy, or agent. Aggregate and calculate data. This is quite important, I think, for like bandwidth monitoring or customer monitoring, where I wish to get some calculation, percentile calculation or something like that for our customer. This is also fully supported. And of course, in some cases, we want to monitor VMware environment, and Zabbix integrates with that quite nicely out of the box. Then we also have web monitoring, which works for simple website logic. Perform a login, check if login has been successful, perform a forum post, check if forum post has been successful. And what we have introduced, what is fully supported in 5.2 and 5.4, is synthetic monitoring, which is the ability to define our own JavaScript, to create synthetic monitoring scenarios for our websites. This is really amazing. This is something that web monitoring has been lacking for quite a long time. But now we have the ability to define our own JavaScript, define really complex scenarios, and thus implement synthetic monitoring of our websites or anything else by using JavaScript. So let's talk about some of the latest improvements, why I'm focusing on version 5.4, and why I'm saying that with 5.4, Zabbix is truly ready for multi-tenant environments. So in 5.2, before that, we reworked permission logic. We added user roles, something that was in my list of requirements for multi-tenant environments. And we implemented a more granular front-end configuration when it comes to time zones and things like that, which will also be relevant for users located in different locations. In 5.4, we added the ability to send scheduled reports, which is really, really great. Some customers may wish to receive scheduled reports about their environments. And now, instead of utilizing third-party scripts for it, you can use the native functionality. And we also kept on adding performance improvements, especially for really, really large instances. We're talking thousands or tens of thousands new values per second. There are a couple of other things that I'll mention throughout this presentation that could be really useful. They're available only from 5.0 and higher. What is a multi-tenant environment? What do I mean when I say multi-tenant environment? Here's a very, very simplified picture, but essentially we provide Zabbix as a service. Let's say we use Zabbix monitoring tool, and we use it to monitor our clients, client A, B, C, and B, C, D. We monitor their network traffic, their operating system stats, application stats, log files, things like that. For each tenant, these requirements are going to be different. Another thing that we have actually also improved when it comes to performance, and that is really flexible, that is important in multi-tenant environments, are Zabbix proxies. Remember, we can deploy Zabbix proxies in customer environments. And what Zabbix proxies are capable of doing since 5.0 is pre-processing data. So we can change our textual data to numeric data. We can use throttling, which I'll talk about in a moment, and other pre-processing approaches. Even custom JavaScript is supported nowadays to format the data before we send it to our central server. So instead of server being responsible for all of the pre-processing and having quite a large overhead, now the proxy can do it and then forward the data to the server. In addition, proxy compresses the data before sending it. And even if we have a network interruption with the customer's site, proxy is still going to continue collecting data and storing it in its own database. And once again, once we receive data back from the proxy, it gets sent via a single connection, which is a lot more enticing for the networking team. Also, we can execute remote scripts on the proxy, and we can deploy multiple proxies to improve scalability. More proxies, if a single proxy cannot handle the amount of data that we are gathering or pre-processing, we can always deploy an extra proxy. They're easy to deploy. They can even use out-of-the-box SQLite database. So really, really easy, really flexible, really nice to have proxies in your environments. We can also select the direction of the connection. We can have passive proxies, which get pulled. This is the bottom image, which essentially, in that case, the Zabbix server pulls the data and sends the configuration to Zabbix proxy. So Zabbix server is the one responsible for establishing the connection to the proxy. Or we can have active proxies. That's the top image, where we remove that connection overhead from the server, and proxy sends the data autonomously to the server and picks up configuration changes from the server. Once again, depending on usually the security requirements of the customer, we can have both of these running at the same time. You don't need to have all of your proxies in the same mode. You can have a mix of proxies running in both of these modes. Throttling. I already mentioned pre-processing, but oftentimes we will do things such as service checks, right? We will monitor services which can send the statuses such as 1 or 2 or 3, like some numbers, and these numbers will repeat. Let's say we monitor our service every 5 seconds, and it sends us this value up, constantly up, 5 seconds after up, 5 seconds after up, and so on. What throttling is going to do is going to discard these repeating values. It's going to simply just store deltas, right? Not deltas, but status changes. And therefore, we can save a lot on database space, which is very important in large environments like these. Also, less entries in history tables, events tables, things like these, the better the performance. The less we have to worry about scaling our performance upwards, adding new hardware, tuning Zabbix further. This is a really, really great feature. I think maybe at this point in time, I'm seeing some proper utilization in many customer and community environments, But when 5.0 came out, it was severely underutilized. And if you aren't using throttling yet and you're running on 5.0 or newer, I definitely suggest you attempt to implement it. It's available in pre-processing. So next up, permissions are also quite important. Even though we implemented roles, the old good user group to host group relation hasn't gone anywhere. It hasn't been abandoned. It's still there. User group to host group permissions still matter. We have 3 user types. Even with roles, we still have users, admins, and superadmins. And now we can add user roles. And here you have a screenshot from the permission section on a newer Zabbix version, 5.2 or most likely 5.4, where I can see my user role and I can see which UI elements the user has access to, access to API, is it restricted, is it enabled, and what actions can the user do. So when you're configuring a role, you will see a screen like this. You can essentially select the user type. The user type restrictions still apply. Users can get access only to monitoring and inventory. Admins can get access to everything but administration, and superadmins can get access to everything. And then you can restrict. You can have superadmins that can have limited access. They can only do specific actions and access specific UI sections, or you can even further limit your regular users. So they get access to only the things that they need. And this has 2 core benefits from my point of view, at least. One is, of course, security. We can limit what we can do and what we can access. And the other benefit is the UX. I had a separate speech about user roles where I heavily emphasized how nice this is from the UX perspective, where our users, especially users that aren't familiar with Zabbix, maybe users that aren't certified specialists or professionals, just beginners or regular not team users that have to work with tens of systems and they aren't concerned with learning Zabbix specifically, we can limit what they can do and what they can see, especially per customer, right? We assume that our customers aren't like professionals with Zabbix. So we can limit the buttons, essentially, the sections that they have access to. So they won't be concerned with like navigating through multiple sections and subsections. They will get access to they will have access only to what they need, which is really, really great. And then, of course, we still have user groups and user group relations to host groups, which we have to be concerned. So we have to define our user groups and assign either read or deny permissions on host groups. And this is how we limit which customer can see what specifically. In addition, I think something that many users aren't familiar with, we can have host groups defined in a hierarchical manner. For example, I have 2 customers. I have customer ABC, and then I have a subgroup, customer ABC network devices, customer ABC servers, then customer DEF, and the same sort of logic for customer DEF. And then when I'm assigning permissions, I can actually select to include the root group and all of its subgroups when I'm assigning user group to host group permissions, which is really, really elegant and really quick way to give a user, an admin, super admin from the customer side, maybe access to all of the necessary user and host groups, or a regular admin, most likely, not super admin, but yeah, regular admin, because super admins still have read-write access to every host and host group. So we're talking about admins here. Next up, so we have configured our users, our roles, deployed proxies. We'll talk about proxies, actually. We'll return to that. What about from the kind of infrastructure point of view? So high availability is a must in this case, because we need to have our uptime as close as possible to 100%. And we can use high availability. Right now, we support Linux high availability tools, PCS, CoroSync, Pacemaker. And of course, if you wish to use some sort of other third-party tool, this is fully welcome. Use what you're familiar with. This is just something that we try to use and stick to in our environments. And this way, we can have a set of, for example, 3 servers. 2 servers is not a good idea, because in that case, it's problematic reaching quorum, and split brain scenarios can happen. In this case, we have 3 nodes. We have Zabbix server A, Zabbix server B, the arbiter node, which essentially provides us quorum. So we need to have at least 3 devices in this case. Otherwise, if we have only 2 devices, we can't achieve quorum. We can't decide a server A down or a server B down. With 3 devices, and this arbiter node can be a really small node. It doesn't need to be like a resource-intensive node. It can be just essentially an arbiter, a small arbiter that tells us, okay, yes, either node A or node B is not available. And so in this case, as you saw with 3 nodes, odd number of nodes is recommended, generally 3, 5, 7, so we can achieve quorum. So there's no scenario where quorum isn't achieved. In this case, we support only active passive cluster architecture, so we cannot have 2 Zabbix nodes running at the same time, talking to the same database. This will cause issues with database consistency, and this can essentially cause crashes down the line, issues with queries, with cleaning up data, inserting data, and so on. So you don't want to have it. And that's why it's quite important to use some sort of shoot the other node in the head mechanism, stoneth, to avoid such split brain scenarios. This would be a mechanism. The stoneth mechanism would be a mechanism to avoid such scenarios. In addition, let's return to proxies, as I said. We can have our proxies in HA. Nowadays, I see such a requirement more often. 3 points here. Before we implement HA, let's decide, do we really need it, all right? Because this adds a lot of management overhead. We can have hundreds, if not thousands of proxies. And managing HA for each of those, yeah, it can be quite painful. Of course, if you're familiar with the HA suite that I specified, PCS Corosing Pacemaker, or some other HA suite that you use, then maybe it'll be, yeah, a simple deal for you. Another approach that we can use is API. We can essentially have 2 proxies running without the need to have that HA suite. And if proxy A is down, we can use Zabbix API to essentially move hosts from proxy A to proxy B. Here I'm using host mass update to change my proxy. So these hosts will be now monitored by a different proxy. Once again, of course, not as simple as it looks, but it's definitely a possibility. Now, if you wish to have robust environments, then some complexity is unfortunately a must-have. That's just something that does happen. We've talked about application servers. With front-end servers, we can simply bring up additional front-ends, maybe by utilizing Docker. What about database? With database, we can actually have multiple nodes, Postgres, MySQL, Oracle, and utilize the native replication or use some sort of third-party tool for replication. Things such as Galera cluster and so on. Though I prefer using native application. Why? Native replication. Why? Because it's a bit more simple. I don't wish to learn personally Galera on top of the things I already have in my backlog of things to learn. Or maybe I do. Let's just imagine that I'm an admin that doesn't want to learn Galera. So I will use native, in this case, MySQL replication, and I can set it up in different ways. Master slave, master master. I can even have multiple masters, 3 masters over here replicating to one another. So yeah, it's completely up to you how you wish to implement it. Like I said, I prefer, in case of MySQL, using native MySQL replication tools. But if you are familiar with some other cluster software, then of course you're welcome to use it. Let's not forget about performance tuning. Even though we have set up replication here, we still need to tune our databases. The database defaults, especially in such large multi-tenant environments, they probably won't cut it. In your home office, they most likely will. In an environment with tens of thousands of new values per second, or even simply thousands of new values per second, they probably won't. Of course, these defaults depend on the database and database version that you're using, but ideally, please do tune it. Especially do it during the design stage before you have deployed your Zabbix. Install the database backend, take a look at the hardware resources that you have available. Ideally, you have already estimated the hardware resources required for your instance and tune the database accordingly. Here I have a screenshot from PGTune, which is an online tool for tuning Postgres, just one of the available approaches or tools that you can use. Ideally, you would have a DBA on hand that is aware of what kind of data loads you'll be receiving and dealing with, and he can help you tune the database so it utilizes your database resources. Partitioning, another step. Most likely in such large environments, you will see that Housekeeper cannot keep up with the amount of data that we are storing. He cannot clean it up in a timely fashion. Housekeeper process will go sky high, will reach 100% for 20, 30 minutes at a time. And this will have a negative effect on the overall database performance. At that point, it is recommended to implement partitioning. We can use Postgres with Timescale plugin nowadays For this, the partitioning is supported out of the box. You can actually configure it in administration general housekeeping. For MySQL, for example, there is a community solution provided by one of our partners over here, prominent community members. This was presented in one of our blog posts. So if you wish, you can open this here, a GitHub page with the partitioning script and look at our blog posts. And the community member there describes how to set it up. One of the many partitioning scripts. You can always create your own, but ideally be aware of what you're doing and how things should be partitioned. We are partitioning only history and trend tables. With TIMESCALEDB, as I said, things get a bit more simple. Partitioning is defined out of the box. We don't have to rely on community scripts. And we need to specify on TIMESCALEDB the chunk time interval parameter, which will define the partition chunk size. In addition, we can also add compression of the data, and this will greatly, something like 60, 70, 80%, reduce the database, the history table size, and thus the database size. Because once again, in such scenarios, your database is going to be huge, probably terabytes in size, with tens of customers, each having thousands of metrics per second. So compression is really valuable here. The only thing that we have to take into account here is that compressed data, it cannot be changed post-compression. So no more changes or inserts in the compressed chunks. So let's summarize before I get to the Q&A section. So we need to use at least version 5.2 for the role support. Right? Ideally, if you wish to wait for LTS version, 6.0 is something that I would recommend waiting, because that is an LTS version supported for 5 years. 5.2 isn't supported anymore. Currently, we support 5.4 until 6.0 is released. So if you still have some time, maybe wait until 6.0, which will include all of the features in the previous versions, and it'll be supported for 5 years, which is, I think, quite a large amount of time. Don't forget to deploy proxy servers, define and configure HA on them if need be, same as with Zabbix server and databases. Implement partitioning. Implement throttling. As I said, some time ago, I noticed that throttling was underutilized. Nowadays, I think it gets its fair share of usage, but if you aren't using throttling, get on it. It's very, very useful. And don't forget to tune the database. Very important. Unfortunately, I see it more than I'd like to see. Databases running with database defaults, they have to be tuned in most cases, even in your home office. Let's just abide by the best practice. Let's learn a thing or two. Let's try and tune our database to get the maximum performance. And that's our checklist. And this way, with implementing all of these features, we can have our Zabbix environment with redundancy, monitoring tens, if not hundreds of customers, multiple proxies going on, maybe for each of the customer, HA in place, and Zabbix performing up to our expectations. And that will be it. Thank you. And I can see we have a single question in the Q&A section. So as I already mentioned, I didn't cover it because I did see this question. In 6.0, Zabbix will have a native, at least so far it's planned on the roadmap to have a native HA solution. From what I've seen so far, and it's still in development, so what I can say is very limited, it looks very, very plug and play. So those are good news. As soon as we have an alpha or beta ready, hopefully you'll be able to get your hands on it and test it out yourselves and give us feedback. But from what I'm seeing, from what I'm hearing, should be quite elegant and quite simple, and remove quite a lot of management overhead when it comes to monitoring application HA. For the databases, we will still though have to rely on replication if you wish to implement some redundancy on the database layer. So yeah, to answer the question is, will it be the whole package, or does it involve installing individual components and maintaining them? So the HA will be for servers. Not sure about proxies, actually, haven't looked at it. Maybe also for proxies. If not, then it's just a matter of time. For databases, currently, you will still have to resort to replication. Let's see, we have some other questions. Give me a second, I'll just go through them. Can I run Zabbix on a single server and sell monitoring service to several customers with fully isolated environments? Not just GUI, but also items, triggers, process. Yeah, you can, definitely. That was the use case. We can even scroll back in our slides over here. I will still have the screen share on. So in this case, we have our single Zabbix instance, right? And we have multiple customers being monitored by this instance. The only thing that probably will be required is deploying proxies on the customer side. And by using what we discussed, permission restrictions, proxy servers, pre-processing, things like that, we can then monitor multiple customers from a single Zabbix instance. Yes, this gets done. This is actually a use case that I see quite often. For proxy HA, changing proxy, when we change proxy, the agent configuration has to be updated. That really depends on the approach. If the agent is getting pointed at the virtual IP address and the HA is managed by PCS Crossing Pacemaker, then it should get fine. The VIP should just be on the currently active host. So you'll be essentially rerouted. With the API approach, you can, out of the box, allow your agent to get monitored, to get polled, for example, by both of the proxies, and also in server active, we can also specify multiple hosts. So agents can actually be prepared for this. How to merge two different instances into a single monitoring instance. This is a complex task. Are they the same version? Are they different version? Maybe you can simply migrate the history from one instance to another, but then we will have some problems with underlying IDs, because on instance one, we have our own set of items, triggers, users, and so on and so forth, and they have their own set of IDs. On the other instance, the set of IDs will be most likely conflict with the initial set of IDs. You can do a partial migration. You can use the export function to export your templates and hosts, value maps, regular maps, and try to use the export function. I would try to export as much as I can that way, because migration on SQL level, it will be a real pain in the back. I'm not saying that it's impossible. Everything is, of course, possible if you were intended on doing it, and if you're stubborn enough. But it will be really, really complex task that will take you probably weeks to fully implement. Let's see, we had one more question. Do subgroups relate to templates as well? Subgroups relate to templates in a way that we can also define permissions to reading templates, right? Reading and modifying templates. So for templates, you can also create per customer templates and assign them to host groups in the same way as we did with the hosts. What will be used for out-of-the-box HA in Zabbix 6.0? So it will be native Zabbix HA, essentially configured in the Zabbix code, where you should be able to have multiple servers running. And of course, only one server at a time will be communicating with the database, but Zabbix will take care of essentially like moving from server to server natively. Is there any example for Zabbix HA and Zabbix blog? Yes, there is. Essentially, if you simply just Google Zabbix high availability and blog, or Zabbix blog high availability, you will see a couple of examples for HA. So yes, they are there. Let's see if we have anything else. Okay, I think that is all. So thank you guys and girls and everyone else out there quite a lot for attending this meetup. Yes, only 2 presentations, but I think really, really great use cases over here that we covered. I'm glad that you guys attended. I hope this was useful. The recordings, as always, will be shared and available online.